In this lesson, we'll use the zeros of a function to get the graph, and we will study different ways that a function behaves at the zeros. The zeros of a function are those numbers that make the function zero. So here we have multiplication of x times x minus 4 times x plus 3. So we want to find what are those numbers that make that multiplication zero. And of course, if we know those three, when we multiply them, gives you zero, then at least one of those, if not all of the three, are gonna be zeros. So it's not too hard to see that x equals 0, x equals 4, and x equals -3 are the zeros of the function. So right here, -3, because when you replace here -3 plus 3, that becomes 0, and anything times 0 equals 0. And same thing with x equals 4 or x equals 0. So knowing that those zeros, now we're going to use some particular values of the function to get the graph, specifically what the sign of the function at certain values. So we will consider 1, 2, 3, and 4 regions of that line. And we will study, the signs before -3, then between -3 and 0, then between 0 and 4. You can see that here, and then after 4. And we can see that the multiplication, this first section is negative, then in the second section is positive, then is negative, and then after 4 is positive. So that gives us an idea of what the graph looks like, right? So this is going to be a continuous function. That is a particular property of polynomials. It is continuous, meaning you could draw this part of the graph without lifting up your pencil. And you will know that this will continue forever towards negative infinity, and it will continue forever towards positive infinity. So that's why the arrow was there. So we get an idea of what that group looks like. So we should try to do this one right here. It is not factored, but we can probably factor that without too much difficulty. You will pause the video and you will check your answer. So if you check the answer, there you go. And you can use Desmos to verify that that is in fact the answer. There is another try right here. Could be a little bit harder, but worthy to try it. So pause the video and check your answers. All right, so now let's try to go to example 2. So hopefully you guys remember what the graph of a line looks like if you had right here f of x equals x. This is a line, right? And if you had f of x, x equals x squared, sorry, then we know this is a parabola. Sometimes this one opens upward, but we also have, if we had f of x equals x to the third power, so we'll get something like this. And it's not hard to use Desmos and verify that those are the actual ways that the graphs behave when it is x squared and x to the third power. So now the idea is we want to see what happens if a zero has multiplicity. You know what that is. Could be like an odd multiplicity right here, or an even multiplicity, which is going to be exponent even. Whereas in here, these two could be classified as the same because basically we see maybe there will be a slight difference. You will see it later. So right here, for example, we want to graph this function, and we can see that depending on what value a takes, the function behaves in a different way. So if a equals 1, which is x minus 1, exponent 1, so of course we're thinking of the line. So we can see that the zeros that we have behave like they cross. When we look at, if we were to look at this in a microscope, this will be like two lines, one line right here, one line right there, right? But if we change that to maybe 2, now we have at x minus 1, that's this point, this blue point right here, we can see that there is like a parabola, right? Because now my exponent is 2. But what if it is x equals 3? So now you can see that cubic function here at the same point, x equals 1. So that's the main point of this multiplicity. So the multiplicity of a 0 basically is the exponent that that particular factor has in the function once you factor it, right? So it could be multiplicity 1, multiplicity 2, multiplicity 3. We'll study those 3, but any even multiplicity will behave the same as if it was 2, and if it was an odd number greater than 3, then it'll be basically the same as if you had multiplicity 3. So the main 3 differences are the exponent equal 1, the exponent equal 2, and the exponent equal 3. That's the only thing that you have to do. If you had like 4, for example, we are gonna have back that parabola that we had when we had exponent 2. If we had 5, then it's gonna be, yes, a little bit closer to the x-axis, but still you can see that shape that is the cubic form right there. Okay, so we can use that to describe the behavior. So there are 3, either there are 1, 2, and 3 zeros. So we should be able to describe if it is crossing, if it is a parabola, or if it is like a kind of cubic shape at the x-axis. So let's see what the answers here are. Pause the video, and if you have tried something, compare your answers. So the graph crosses at this 0 and -4 and has a turning point because this 4 is even at the 0, x equals 1, right? So same kind of thing we can do right here. Hopefully you guys tried something. So when we're here, so the graph crosses where it is right here, crosses at x at the 0, 1. So right here, and has a turning point at the 0, -2. So this is even, this is odd, right? This here is not any real number, because remember, x squared plus 9 cannot never be negative. So only if x takes like complex number. So this is not going to be represented in the graph, but there will be 2 real zeros the function has. Okay, so our last example, people, I don't want to make this video too long. It's going to be example 5. And this is very easy if you think about one way. One way to solve this equation here is to have like an equation with a 0 to the right, and that will be like subtracting 3x to the 3rd power, subtracting 8x to the 2nd power, and subtracting 1. So you will get something like this. And if you find the roots of this equation, those correspond to the zeros of the function. So if I got this function here, well, first I'm going to factor, and this particular example, you might find it kind of challenging, but this is how you factor that. And of course, if this number raised to the third power equals 0, that means that the function has a 0 of multiplicity 3 at x equals -1. So that solution is x equals -1 because it just repeated 3 times, and that would be your 0. You could check your answer by using Desmos. That's another thing that you can do. You can graph this function to the left and also that function to the right, and find the x-intercept, or much better, the intercept, the x-coordinate of the intercept between those two graphs. So see if you can do this here, and any questions you can always find a way to ask me. So here is one. So there are two right there. And for the other one, you can do this here. And you're going to find two complex solutions and to the equation and two real solutions. All right. So I will stop the video right there.